How is that possible?
What?
How does the larger hexagon have a smaller perimeter
Than the circle?
than the smaller hexagon?
The smaller regular hexagon. Yeah. Where did you see it has a greater?
Like line 20. It says the larger hexagon's perimeter is 4 root 3, which
Ah,
doesn't make sense.
I'll show you why. Because 4 root 3 is bigger than 6. That's why. Yeah,
That's
6
weird.
point,
Okay.
6.9. Mm-hmm. Okay. Did you read all of it?
Yeah.
Summary of. So then I'll now. Okay, so this one. Oops.
Um,
So explain why perimeter of the smaller hexagon is 6.
because the radius of the circle is 1,
Mm-hmm.
and the hexagon is split into 6 equilateral triangles.
Yeah.
So, like the edge of the hexagon is also 1, and then it has 6 edges.
Yeah.
Perimeter is 6.
Yeah. So like O to A is a radius of the circle. It's also the midpoint of A to D, and so that would be 1.
Why do you have to say that it's the midpoint of?
I suppose I don't actually. Let's see. O to B is also 1.
Mhm.
Or maybe you don't need to say that. Yeah, it's an equilateral triangle. And so if O to A is 1, then A to B must also be 1. Something like that. There we go. Okay.
Um,
So show that the larger regular hexagon has this perimeter.
its edges of the circle. I'm not really sure how you show that.
Let me just. Let's see. And let's just get stuff. So pi, sure. Story time. So basically, the circumference, yeah. Okay. So from this one, for root 3. So we could just try to find the perimeter. So this bit is the midpoint of A dash B dash, or I think they call them A prime, B prime. So that's the midpoint. So it'll be double that. It would also be a tangent to the circle.
Yeah, but I don't know how that helps you find the length. Or you could do like a right angle triangle from O to like the midpoint to, I don't know if you would do to B dash. But no, you wouldn't know the length, so.
If it was a right angled triangle, it would have to go like straight down or something.
Yeah.
Does that help? We could go like that.
Yeah, that's what I thought. And then you could, you know that O to the circle is 1.
Yeah.
You don't know, but then you don't know 2 for the side, so I don't know how that would be helpful.
If we were doing Pythagoras, it would be, I'll call that M. OM squared plus AM squared.
Okay, but OM is 1. You already know that. Is equal to O A dash squared. O again.
Yeah. And let's call that OA plus something like that.
Yeah.
Yeah, we still have that unknown though. Let me just try something else. So we know from pen doesn't work. We know from O to the midpoint.
It's 1.
We know from O to this midpoint. Straight down, would they meet perfectly? I believe they would.
Would that I thought that wouldn't give you the length of the hexagon.
It wouldn't.
Yeah, you could do a kite, but I don't know. That would be helpful.
That makes a kite. I don't know. We know this is 90. This is 1. This is 1. This is 90. Is this also 90 degrees? Are they all 90 degrees?
I don't think so.
I think it's answer time. Let's see. So I got this one. don't even know where this is. Oh, this is a sample one. Mark scheme. So we had 12 and 13, I think. Triangles equilateral. Tan 30. A dash to the midpoint. That's 90. How do they know this is 60 and that's 30?
Because the triangles are equilateral. So.
So that's there. Of course. So this total would be 60.
60, yeah. So that'd be 30.
So just in there is 30. And so this has to be 60.
60. And the other one's 90, obviously. Yeah, then you can just do tan. Or you could do cos 60 and then do a dash m or whatever, yeah, over 1. So a dash m is cos 60. Probably should know that. Half.
So that's a half. Uh-oh.
That doesn't that just give you the length is 1?
Yeah. Something's wrong.
Yeah.
Cos is adjacent over. It's the other way around. Is it 1 over a dash m? No.
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 That is adjacent, so I'm confused.
Did we do this right? That's an equilateral triangle. Hang on. No, I think maybe I'm wrong. Let's look at this. So this bit here, how do we know that that's halfway? Yeah, it has to be, surely.
That's the center, so it has to be.
Yeah, so if you were to do that, like that angle, halfway would be the midpoint. So that's definitely 30 degrees there. Yeah. This is...
It's the right, angles.
That's 90.
Because even if you drew the triangle like that with A dash and B dash, it's still equilateral, so it'd still be 60 degrees there.
Yeah.
And it has to be 30.
And so, let's see.
I don't know why it didn't work with codes, but...
So if we call that X, let's do sine. Sine 30 equals X. I mean, that'll be the same number.
Yeah, sine 30 is equal to cos 60.
Yeah.
Something is wrong.
What are we doing? 60. So the angle A dash N, did I mean A dash ON?
Probably.
So are they saying
How is
this
that
angle?
tan 30? That is just 30.
Are they saying this isn't 30 or something? Hang on. A dash N as an angle doesn't really... Tan 30 is opposite over adjacent.
How is the opposite 1? If tan 30 is there, the opposite is not 1.
That's why it's this. No, because this is 1 plus a little bit extra. So this isn't 1 down here.
1 is there. Okay, that makes...
There we go.
Confusing.
Yeah. And
So
7.
tan 30 is 1. But it's opposite over adjacent. Oh,
So,
x over 1.
yeah.
So tan 30 is equal to x, which is root 3 over 3.
3. This thing's going
And
crazy.
then when you times that by 6, wait, no, times that by 12,
Mm-hmm.
it gives you 4 root 3.
Equals 4 root 3. There we go. That was just this diagram.
Yeah.
Okay.
These comprehension questions are pretty hard though.
I agree. Let's see. Did I lose my spot?
I have to do it for biology as well.
English. Why? Question. We did 13, 14.
Show that the two values of b. Okay. I don't know. They are.
Given on line 36.
B is equal to root 2 minus root 3. Okay. Fun.
So show that what is equivalent to what?
That b equals root 2 minus 3 and root 6 minus root 2 2.
So
I've literally never seen that before, so. Okay, I don't know if you would do this, but would you multiply it by like square root of 2 plus root 3?
we'll give it a go.
Because that, like, rationalizing.
5176. So it is the same. We've got that part so far. Rationalizing
Is how you do this. Because I don't know how to otherwise.
So this, let's try multiplying. Let's try multiplying it by itself over itself. So 2 minus root 3 over 1 times by 2 minus root 3.
Isn't that just squaring it?
Well, the problem is if you square it, you'll change its value. You'll make it bigger. And so we have to...
Oh yeah, this is just multiplying by 1. Okay.
Yeah.
I'm not really sure how to multiply them.
So you got it right when you said it's the same as squaring, eh? Sorry.
So it's just 2 root 2 minus
2. Yeah, so what is that squared?
how do you 2 minus root 3?
Yeah. What goes on the bottom?
Square root of 2 minus root 3.
Oh, that didn't help. That didn't help. It just moved it to the bottom.
Yeah, it will just cancel out now.
Then it just goes back to being what it was, I believe.
Yeah, it just goes back to square root of 2 minus root 3.
Let's try something crazy.
But surely rationalizing also doesn't change the value because it's also multiplying by 1.
Yeah, it doesn't. You really want to try that rationalizing thing? Okay, so you want to multiply this by
2 plus square root of 2 plus root 3.
All right, how do you do
that? It's difference of 2 squares, so
I don't even know how you do step 1 on that one. I have a crazy idea.
Don't know what either.
2 is the same as square root of what?
4.
Does that do anything? So b is the square root of root 4 minus root 3.
I don't think it does anything.
Let's see. That if you multiply this by, so how do we get that as root 12? That's root 12, but only if you multiply.
Root 12.
That would be over root 3. Nah. Because then you could get this one as root 12 over root 4. But then you still have a square root. This might work, but might not. Let's see. So common denominator would be root 12. So it would be root 4.
What if you did rationalizing, but you ignore like the second square root and you only rationalize the 2 minus root 3 part?
Okay.
Would that work? I don't know if that would work. I don't know what's going on there either.
Hang on. So this one, we could.
What if you just do 2 minus root 3 times 2 plus root 3 over 2 plus root 3? And then you can put it like all under the square root at the end.
Yeah, you could do something like let root 3 be equal to a or something.
Oh, that's not what I meant, but we could try.
So it'd be like 2 minus a.
I thought you can just like the big square root can basically kind of ignore it and then rationalize and then put it all under the big square root at the end.
Go on. So what do you
So
mean?
like do 2 minus root 3 multiplied by 2 plus root 3 over 2 plus root 3.
Okay.
So then that would just be 4 minus 3, which should give you 1. Over 2 plus root 3.
Mm-hmm.
And then you do square root of 1. Okay, that's not really helpful. Square root of 1 over 2 plus root 3. I don't know if that would work or do anything.
The square of everything, is it?
Yeah.
So that's
I
essentially
don't know if that's helpful.
That's essentially just the square of the bottom then.
Yeah. Okay, it's not helpful. Never mind.
I think we got that earlier. If we were to now rationalize this to multiply it, it would be 2 minus root 3 on top. It would go back to being what it was, I believe.
B, not H, but yeah.
Oh, yeah. Oh, hold on.
Very different.
Hold on. Maybe then. Okay, let's try rationalizing this thing then.
So that would give you 2 minus root 3. Square root of... Wouldn't that just give you over 1?
Over 1. Oh, that just went back
That would
to...
just go back to the original, so it's not helpful. I honestly have no clue what's going on.
I think, well, before I go...
Could you just square everything? Would that work?
Well, you could square 3, you'd get 9, you know. You just change the number.
Yeah.
This method might work. Let's see. So I just got them to be both...
Oh, somehow. Yeah.
Root 12. You do that. You could bring them together. Oh. No. Well, I was just going to think you can factorize out the root 12. You get root 4 minus root 3. And the square root of that. But that's the same as that. All right. Answer time.
These are impossible.
Oh, come on. That's cheating. They worked backwards.
That's easy.
root.
That's okay. That's pretty easy. I do know how to do that.
Okay, I didn't know we were allowed to do that though.
Yeah, I didn't either. Probably.
Hang on. So they squared it. And they got that. 8 minus 2 root 12 over 4. Which is simplifies down to 8 minus
4 root 3. And then factorize out the 4.
So that makes 2 minus root 3. That is positive, so it is equal to the square root.
I don't like their argument, it is positive. But you can tell that obviously if you square rooted it, you would get the same.
It is a length, alright. But okay, I wasn't aware you were allowed to do that. To work the other way.
But it doesn't really say which way you have to do it, so.
Alright. Because usually you're not allowed to do that, but alright.
Are you not?
Well,
yeah, proves you're not allowed to work from.
Yeah, you have to prove you can't just sub it in,
Yeah.
Because then you're using the thing.
Yeah.
Okay, show that the two that are equivalent.
That was one. Yeah, so interesting.
Shows a unit circle with 12 edges.
Show that the perimeter of the polygon. Okay, this is basically the same question that was there before. So that angle, that angle that's been drawn on is 30 degrees.
I don't think so.
No.
It was 30.
Yeah, it is, because you could do, wait, is that one edge or a midpoint of an edge?
So there's now 12 edges.
Midpoint of an edge. So you could do 2. Oh, no, it's not. It's 15.
Yes.
The one in the middle, it's 15.
Yeah.
And then that one at the bottom is 90.
Yeah. No.
No?
I believe this one up here is 90 because it's a tangent. No. This is the tangent down here. Yeah, you're right.
So then the top one is 75 degrees. So then you could just do tan 15 is opposite. X.
Mm-hmm.
And then, yeah, you can, I don't know how to explain this mathematically, but there's 24 triangles in the polygon, so it's just 24.
Mm-hmm.
So it's 24, 10, 15.
Yes, and so the perimeter is you sub that in there.
Yeah.
Oops. 24, 10, 15. Therefore, so okay.
Okay. You get given that formula, I think. I don't know it.
Yeah, sure do. And it's on this paper, I believe.
How are these only 2 marks and 3 marks each? Not fair.
So what does the formula come under?
Trig, yeah.
Right.
So for that tan theta minus the other one, is it meant to be equal to 15? Like what's in the bracket? Like what would you put in the bracket?
You would put in two special angles that have exact values because we need an exact value.
So, but what would give you 15? 60 and 45.
Yeah, something like that.
That would give you. So tan 60 minus 45. Oh yeah.
No, it just it seems so silly because tan 15 is a special angle itself. But anyway.
And then do is equal to 24 times tan 60 minus tan 45 over 1 plus tan 60 tan 45. And then do you just solve that?
I think you have to because it show that
Yeah,
now
like you just use your calculator to find all the values.
yeah, so you now sub in
Okay.
what tan 60 and tan
So
45
tan 60 is root 3
okay,
and tan 45 is 1. So 1 plus root 3 on the bottom.
okay.
Yay. How does that give you 40? Okay, rationalize.
Yeah.
Always rationalize. I don't get why people don't like surds. Like, it's easy. You just have to rationalize. 1 minus root 3. 1 minus root 3. And then that would give you. Well, on the bottom you would have 1 minus 3, which is minus 2. Then on the top you would have oh, they're not the same thing. I'm probably going to multiply this out. Two root 3 minus 4. You could like factorize out 2 and then cancel out the denominator. Like so on the you would have 2 bracket root 3 minus 2. Yeah. And then multiply by 24. So then you have 24 root 3 minus 48. But you could just multiply through by minus 1. 24 root 3.
Sorry, 24.
It's 48.
Root 3.
I don't know why it came out the other way around, but you can just multiply by minus 1.
It's because it's all over minus 1.
Okay. So that's equal to 48 minus 24 root 3.
Yeah. And it seems kind of pointless given that 15 is itself.
It's a pointless question.
Anyway. Okay, so
I don't even think you need to really know maths to do that question.
16
Yay.
on a unit circle.
This is 3 marks. How?
We could use our earlier.
Yeah, the article probably has something to do with this. Like 12 edges. It was down 12 edges.
So this was 12.
Okay, so you already know the perimeter for the outside hexagon.
Yeah.
So you only need the inside one. Like you only need to do the inside one. And the inside one is always just like 12. Like it's just going to be 12.
Yeah, that's a good point.
So you already know the value of the bounds. One is 12 and then the other one is 24 times 15, which is 48 minus 24 root 3.
Yeah.
So in third form, it's just 12. 12 is the lower bound, I think.
Yeah.
And then 48 minus 24 root 3 is the upper bound.
But what goes in the middle?
Pi.
Pi isn't bigger than 12.
Yeah. 12 pi.
Yes. No.
No.
On a unit circle. So we might have to go back to the thing. The article. Did I lose it? So you have that.
That's the thing.
So this is the original one.
Oh, you have to divide it by the circumference or something to get the bounds.
So the circumference.
Wait, if you go down a bit, if you divide the perimeters by the diameter of the circle, you get the lower and upper bounds of pi. Okay. So you have to do that. So you know both the perimeters already. 12 and 48 minus 24 root 3.
So that's the perimeter.
Yeah, and then you have to divide it by the diameter. So 12 is easy, you just divide by 2. So that would give you 6. Still doesn't look right.
No. Well, it depends on what's in the middle. Or pi.
That's true. But wouldn't pi just be in the middle?
Like.
Because apparently once you divide it, it's meant to work. But
pi is... No, circumference should be in the middle.
No. Wait, if you go up in the article, it tells you how to do it.
Okay. But that's what it should be like. Hang on.
No, those are on the out, like on the out. Those are like the upper and yeah, it's meant to be like that.
So this one is 12, is it? And then this one is...
But it's not C over D in the middle. I think it's just meant to be pi.
What is pi?
I don't know. You don't need to know what pi is.
Pi is C over D. How many diameters in a circumference?
Oh, so then why can't you just write pi?
I did.
Okay. So the diameter for the 12 one is 2. I don't know how 6 can be the lower bound for pi.
Can't.
Something is missing.
The diameter...
Oh, because the larger hexagon is meant to be the lower bound and the smaller hexagon is meant to be the upper bound.
Is that right?
Pretty sure.
Okay.
So 6 is actually the upper bound and not the lower bound.
So we flip these two. I can just flip those.
Yeah.
So this one is 6.
I don't know what the diameter is of the other one.
No. You have to do it to... It has to be just the same. It has to be divide everything by...
Yeah, I don't know what the... Are you sure it's meant to be the same? It says you have to divide it by the diameter.
Like, then they're not equal. The diameter of the circle. There's only one circle.
Oh, okay. And 48 minus 24 root 3 divided by 6.
No. Divided by
2.
2.
That's just 24 minus. Wait, no. If you take out 12 root 3.
And 2 decimal places.
24 minus 12 root 3 is 3.22.
No, something's wrong.
Why?
Because that would need to be less than pi, wouldn't it? 3.14. That has to be the... What is the perimeter of... Is the
diameter of the circle? Oh, it is the diameter of the circle.
There's, of course it is. There's only one diameter. Let's see.
But you know how it's... Oh, wait, go down. You know how it says 3 pi 2 root 3? 2 root 3 is equal to 3.46. Pretty sure pi is not bigger than that.
These arrows are flipped the other way.
Are they? Oh.
Yeah, it has to be it has to be this way. The smaller hexagon has to be the lower bound. So we're doing something wrong. If it has dividing the perimeters for pi of 3. So the perimeter of that is 6.
Okay, so the smaller one is the lower bound somehow.
That's because it's equilateral. So 6. It has 6 sides. So when you divide it by 2,
you get 3.
3. We're doing something. So we do this.
But wait, go to that inequality because it says 3. I don't get it. Because how can 6 be less than pi?
This one? So it's saying pi is between 3 and 3.4, which is correct.
Yeah, but if you did it for the question, it would be like 6 is less than pi, which is wrong.
I think what it would have to be is that this here is actually like 2 times circumference or 2 pi or something. You'd half it again.
Maybe.
I think that's what it is. And so that's still 3.
How do you know that it's like that?
Let me see. You told me that. Stop it. So this is where they came from with this for the inscribed. So H.
Maybe we did do the perimeter right.
B. How many sides is this?
The inside one, because I think I just assumed it was 12, and it might not be.
So therefore a regular polygon with 24 edges. I think this is our lower bound.
That times 12. And then divide by the diameter of the circle. Yep, that's the mistake.
Go on, what is it?
After you divide it by 2, it's 3 root 6 minus 3 root 2. And not 6.
2
is less than. Is it less than? Yes. Is less than pi. And then 24 minus 12 root 3. Yay!
Decimals.
3.11 is less. Do you have to give pi in decimal as well? Or?
No. Just the bounds.
And then 3.22. Yay.
Yeah, and so we're getting closer to the...
I don't know if I would get this in an exam.
I don't know if I'd get it either. What kind of helped was they told us that's what. A regular polygon with 12 edges. They told us this bit here, and so they gave that to us. The other stuff we got, we just had to get ourselves. Okay, let's take a look at this thing. Hang on, like that.
This is so hard. Like you have to get through all the other questions before you even get to the comprehension. I think I'm going to do the comprehension part first in my exam.
I'd say do all the easy marks first.
Okay.
And then the thing where you might not get any marks, just do that at the end if you have time.
That's true, actually.
Tan 30. Okay, why was this tan?
Because we put the wrong lengths on the triangle.
So let's see. So this, why was this right angle?
Because the tangent and the radius are always at right angles.
Yeah.
Circle theorems. I remember learning those at GCSE.
How did we get that this was 30 degrees?
Because it's equilateral triangle and it's like meets the midpoint, so it's half.
Yeah, so that'll be half of 60. And so we use that to get the value of x. And why did we multiply it by 12 if there are only 6 sides?
Because it's the midpoint.
Yeah.
So you have to multiply it by 12.
Cheating. Oh, yeah. So the trick here was to work backwards towards this one.
But like we learned that in trig, so
yeah.
Like I thought that was only for trig. Like if you can't do one side, then you have to try the other one. But apparently it works for this as well.
Yep. Why was this 15?
Because 24 of them can fit in the circle.
Yeah, so it has to be half of the 12 side one.
Yeah, so it has to be 360 divided by 24.
Yeah. Let's see. Perimeter.
This one is fine.
Yeah, so this one will come up in...
Let's just use the formula.
Yeah, addition angle formula. You just need 2 special angles that will combine to make that one.
Couldn't you use any angles?
No. Because if you put into your calculator
it would be exact, right? Okay.
Yeah, if you put in 59 and 46, tan 59
doesn't subtract to 15.
Sorry?
That doesn't subtract to 15 if you did 59 and 46.
Sorry, 61 and 46?
I think so, yeah.
Yeah, so tan 61, and that's the thing. So you have to find 2 special...
Okay,
Two special angles.
Okay, that's fine.
There are other... You could also do 90 and stuff like that. You know, depending on the number. It's all right. And then just read...
Discussion, okay.
Just read it, actually.
Passage properly.
Yeah, because they gave it to us. 12 inches.
Assume.
Yeah, we can't assume. And I suppose... Let's see if we go...
12.
So the perimeter... Yeah, we just can't assume. Just read it carefully.
Mm-hmm.
Yeah. Let's see. So surd and that. You don't have to give pi.
They can give you the passage before the exam, like they do for biology.
So yeah, that's a good point. They should do that.
But to be fair, the biology one is longer. But still, at least you know what's going to come up.
Comprehension. Is this the same or different?
Different, I think. It's down, but
but that's the bottom.
Yeah, that is section B is the comprehension part. But I don't know. The article is usually in a separate place. I don't know.
Did they not give the article on this one?
Maybe.
So there's view the resource.
That's the sample one. It's the same one.
So yeah. I think it's just because comprehension is new for the spec.
I think it is new.
There's one here.
But that's the same. It's just the paper. Oh, there. June 2018.
Let's take a look. Arithmetic and geometric mean.
That's 2 over root AB, right? Wait, no, that's just root AB. Never mind.
Mm-hmm.
How do they do a squared plus b squared? is greater than 2ab, and then a plus b the whole squared is 4. Oh, never mind. I got it. Is it because they just added 2ab to each side, the inequality?
Which one are you looking
at? Line 5, where it's like a squared plus b squared is greater than 2ab.
Yeah, it's like they brought it to the other side. Because that'll be like a squared minus 2ab plus b squared is greater than or equal to 0.
Yeah. But then they went a plus b squared is greater than 4ab. So is that because they just added 2ab to each side? Right?
Where is that?
The next line. It says
I see it.
Squared. And that's just because they added 2ab to each side, I think.
So a squared minus...
I think they just added 2ab to each side. So.
No.
Yes, 2ab plus 2ab gives you 4ab.
But they didn't add 2ab to the left side.
Yeah, you do, because a squared plus 2ab plus b squared is equal to a plus b the whole squared. Like if you expand that.
I see, and then they just contracted it back in.
It, yeah.
Yeah, okay.
It's a bit confusing. Took me a second to figure. Okay, I guess.
So they just turned it into a graph. Okay. So you do Pythagoras.
I mean, you don't know what the questions are yet, but...
Euclid's elements. Oh, Euclid. Area of rectangles.
That's it. It's only 3 pages long.
I can't even see one. So this was
June 2018, 2 years ago.
Maybe I pressed it. Oh, wait. Let's just see. Oh, you can see. This is greater than. Explain why the result cannot be extended to apply in each of the following cases. One of the numbers.
Because you can't square root a negative number.
Yeah.
For the first. For the second one, I don't know, because.
What would you do if it was like -3 and -7 or something? -3 and minus.
You just have a negative number on that side.
And what side is in between?
That would work. Oh, you'd have, like, if it was like -3 and -7, you'd have -5 is greater than root 15, which is wrong.
Why is it wrong?
Or root 21. Because a negative number can't be greater than a third, because the third would be positive.
Yeah, any third is always greater than or equal to 0.
Yeah. Okay.
We got one.
Straightforward.
Well, that was only the first
question. Yeah, it's the first question.
Yeah, how was that for you, Amogha?
Okay, I guess. Like, just try and figure it out.
So anything in particular you want to do next time? We can do that other one if you want.
I don't think I can do a lesson for a few weeks because I have exams.
Okay. What are your exams on?
A levels.
Oh yeah.
Yeah.
Well, good
And
luck.
I think this is probably the last lesson.
All right. Well, it was great working with you, Amogha. And
Yeah.
let me know how you get on, because some of my students have been telling me how they've been doing and stuff.
Yeah. I'm applying soon, so
Well, cross my fingers for you.
thank you.
All right. Take care, Amogha.
Bye.
Goodbye.